Hey guys, welcome back to the channel. The Instrument Landing System, or ILS, is one of the most important navigation systems used in aviation. It allows aircraft to land safely, even when visibility is very low. In conditions such as fog, heavy rain, or darkness, pilots cannot rely only on what they see outside the cockpit. Instead, they depend on precise radio signals transmitted from the ground. The ILS provides accurate horizontal and vertical guidance, helping the aircraft align with the runway and descend at the correct angle. The ILS system consists of two main components, the localizer and the glide slope. The localizer provides lateral guidance. It tells the pilot whether the aircraft is left or right of the runway centerline. If the aircraft drifts to one side, the system indicates the direction needed to return to the correct path. This ensures that the aircraft stays perfectly aligned with the runway during the approach. The glide slope provides vertical guidance. It helps the aircraft maintain a stable descent path toward the runway. A typical glide slope angle is about 3 degrees. If the aircraft is too high, the system indicates that it should descend more. If it is too low, it indicates that the aircraft should reduce its descent or climb slightly. This allows for a smooth and controlled approach. In addition to the localizer and glide slope, there are other supporting components. One of them is distance information. In the past, marker beacons were used to indicate specific points along the approach path. These included the outer marker, middle marker, and inner marker. Today, many airports use distance measuring equipment, or DME, instead. This provides continuous information about the aircraft's distance from the runway. Another important element is the approach lighting system. This system consists of a series of lights installed near the runway. It helps pilots visually identify the runway environment during low visibility conditions. These lights become especially important as the aircraft approaches the final stage of landing. During an ILS approach, pilots follow a series of steps. First, they tune the correct ILS frequency for the selected runway. This allows the aircraft's navigation systems to receive the signals. Next, the aircraft intercepts the localizer. This means aligning with the runway centerline. After that, the glide slope is captured. The aircraft then begins descending along the correct vertical path. Throughout the approach, pilots monitor their instruments carefully. They ensure that the aircraft remains centered on the localizer and follows the glide slope accurately. At a certain altitude, known as the decision height, the pilot must make a critical decision. If the runway or its lights are clearly visible, the landing can continue. If not, the pilot must execute a go-around. This means discontinuing the landing and climbing away safely. This decision is essential for maintaining safety during low-visibility operations. Modern aircraft are often equipped with advanced autopilot systems. These systems can track the ILS signals automatically and assist the pilot during the approach. In some cases, aircraft are capable of performing an automatic landing, also known as autoland. Autoland is typically used in very low visibility conditions. Even then, pilots continuously monitor the system and are ready to take control if necessary. Although the ILS is highly accurate and reliable, it does have some limitations. It requires ground-based equipment, which means it is not available at every airport. The signals can also be affected by terrain, buildings, or other obstacles. Because of these limitations, newer technologies such as satellite-based navigation systems are becoming more common. In summary, the Instrument Landing System is a precision approach system that provides both lateral and vertical guidance. It allows aircraft to align with the runway and descend safely, even when visibility is poor. The ILS remains a fundamental part of modern aviation and continues to play a critical role in ensuring safe landings around the world. Thank you for watching.